Pydantic AI's core mechanism for giving an agent actionable capability is the function tool, registered through decorators or the agent constructor, paired with dependency injection via deps type and RunContext, so that runtime values reach the tools that need them. The code below demonstrates exactly this pairing in a minimal dice game where the model must decide for itself when to roll and when to retrieve the player's name. You are about to see an agent initialized with a flash model, a deps type of SDR, and static instructions that frame the model as a dice game, followed by two tools, one plain and one context-aware, and a single synchronous run passing the player's name as the dependency.
Import random. From Pydantic AI import agent, RunContext. Agent equals agent. Google GLA, Gemini 3 Flash Preview, #1. Deps type equals SDR, #2. Instructions equals. You're a dice game. You should roll the die and see if the number you get back matches the user's guess. If so, tell them they're a winner. Use the player's name in the response. At agent tool plane #3. Def roll dice SDR. Roll a 6-sided die and return the result. Return SDR random, random 6. At agent tool #4. Def get player name text, RunContext SDR. Get the player's name. Return ctx.deps. Dice result equals agent. Run sync me guess is 4. Deps equals and #5. Print this result output. Congratulations, Anne, you guessed correctly. You're a winner.
This sets up a basic Pydantic AI agent with a Gemini Flash model, wiring player name as a dependency via deps type equals SDR and passing deps equals an at runtime. Two tools are registered. Roll dice with it agent tool plane since it needs no context, and get player name with it agent tool to access ctx.deps. The instructions tell the model to compare the dice roll to the user's guess and personalize the response. The agent runsync call passes the user prompt and dependency together, letting the model orchestrate tool calls and compose the final output. Using toolplane for roll dice avoids unnecessary context injection overhead, while at agent tool for get player name gives the model access to deps. This dependency injection pattern keeps runtime data like player names out of instructions, making the agent reusable across different players without modifying static prompts. Let's break it down.
Import random. From Pydantic AI import agent, RunContext.
Imports random for generating random values, and brings in agent and RunContext from the Pydantic AI framework.
Agent equals agent. Google GLA, Gemini 3 Flash Preview, #1.
Creates an agent instance configured with the Google Gemini 3 Flash Preview model as its default LLM.
At agent tool plane #3. Def roll dice SDR. Roll a 6-sided die and return the result. Return SDR random 6.
Registers a plain tool function that rolls a 6-sided die, returning the result as a string.
At agent tool #4. Def get player name text, RunContext SDR. Get the player's name. Return ctx.deps.
Defines a tool function getPlayerName that takes a RunContext SDR parameter and returns ctx.deps. The docstring describes it as retrieving the player's name.
Dice result equals agent. Run sync me guess is 4. Deps equals and #5.
Calls the agent synchronously with the message, my guess is 4 and dependency instance, and storing the completed result in dice result.
Print this result output. Congratulations, Anne, you guessed correctly. You're a winner.
Prints the agent's response text. a congratulatory message confirming Anne guessed correctly and won. The whole trick is splitting tool responsibilities so the model gets what it needs without bloat. Roll dice is a self-contained action the model can invoke whenever it wants, while getPlayerName pulls the player's name from ctx.deps at runtime. Deps type equals SDR, and the deps equals Anne pass to runsync wire that name into the context before anything runs. The instructions stay generic on purpose. They describe the game logic but never hardcode a name, so the same agent can serve any player. Tool plane on roll dice sidesteps context injection entirely for tools that don't need it, while at agent tool on getPlayerName gives the model a door to the dependency. The model decides when to roll and when to fetch the name, then composes the final output based on both results. That's the full loop. Dependency flows in through deps type and deps. Tools surface that data or perform actions, and the model ties it together.
Deps carries Anne's name, but roll dice answers first. And the agent knows before asking why.